Welcome back to this class. In this class onwards we are going to discuss some important questions from each units, and after finishing all the units we have the plan to give test series for each units, and these questions are also for the PGTRB exams and for Polytechnic exams. From unit number 12, the first question is, if the reduction potential of Fe2 plus by Fe is equal to minus 0.44 volt and the reduction of Fe3 plus to Fe2 plus is plus 0.77 volt, then the value of the cell Fe3 plus to Fe is asked. The first reaction, Fe2 plus to Fe, for the reduction of Fe2 plus to Fe, 2 electrons are involved, but in the second Fe3 plus to Fe2 plus only 1 electron is involved. So number of electrons involved in each case is different, so we can't use the direct method, we have to use it indirectly. Fe2 plus 2 electron is equal to Fe. This is the E1 is reduction potential is given as minus 0.44 volt. Since its change in Gibbs energy is equal to, we know that already delta G1 is equal to minus N of E. E is the reduction potential, N is the number of electron used, F is, we have to keep it like that, we are not going to change it, minus 2 F into G minus 0.44, it will become plus F 0.88 volt. The second reaction, Fe3 plus electron gives Fe2 plus, and the reduction potential is plus 0.77 volt. When you put this in this equation, delta G is equal to minus N of E, its value will become minus 0.77 F volt. But the net reaction is Fe3 plus 3 electron gives Fe, and its change in free energy will become delta G is equal to delta G1 of this reactions plus delta G2 of this reactions. It will be, when you add this change in free energies, you will get the Gibbs free energy change of this reactions. When you add this, you will get minus 0.11 F. When you rearrange the equations, E03 of this third equation will become minus 0.11 F by minus 3F. So its value will become minus 0.036 volt. Since its value has become in the minus, since if the EMF is minus, it will not be the feasible one, but delta G should be the negative one, but it should be the negative one. So this area from cell is not a feasible one. Now I'll go to the next question. This is the next question. The main assumption involved in the derivation of the Debye-Hückel equations are, for the derivation of the Debye-Hückel equations, the assumptions are given here. Only the Poisson equation is used. During the derivation of the Poisson Debye-Hückel equations, both Poisson equations, Boltzmann distributions are assumed for the derivation. And at the same time, its value of plus or minus Z E psi greater than kBt or less than kBt. The charge density, this information is given in the Puri and Sharma and Patania book, the electrochemistry they have given here. You can take from that book also. Charge density P is equal to minus Z 2 N square E square psi by kBt, kt. And the condition is E psi is equal to less than kt. E psi should be less than kt. This is the assumption used, and the Poisson equation is used to the calculation of potential of the equations. Potential will become del square psi is equal to minus 4 pi ER. So these are the things. The only condition which is not is this E psi plus or minus Z E psi greater than kBt. This is the wrong one. All others are okay. Now the next question is, this is the next question. The base hydrolysis of transition metal complex Ml6Z plus. This is the charge of the complex is Z plus. The slope between log K by K0 and I is found to be minus 2.1. The change in the charge of the complex, they have asked about the charge of the complex Z plus, and charge of the hydroxide ion is minus 1. Charge of the complex they have asked. Log K by K0 versus I is given in this graph. This is the, we can draw minus log gamma plus or minus or log K by K0. Both are same. This is the gamma plus or minus is the mean activity coefficients, molar activity coefficients log K by K naught versus I will give the slope of minus 2.1. So this is the options are given here. This is the equations. Ml6Z plus OH minus gives hydrolysis. The charge of the complex is A and charge of the complex OH minus is B. From the Debye-Heckel equations, log K by K naught is equal to 2A. This is the constant value, ZA, ZB, root I. This equation is in the y is equal to mx plus c. C is 0. M is the slope of the equations. Since m is equal to slope, its value become minus 2.1. 2a, ZA, ZB is equal to minus 2.1. The a is a constant, its value becomes 0.509. And ZA is the charge of the ion A. Ion complex is A, we have taken as such. And the B is the charge of the hydroxide ion, it will become minus 1. So when you rearrange this equation, ZA is equal to 2.1 divided by 2 into 0.509, it will value will becomes around 2. So the charge of the metal complex is 2. So now we'll go to the next question. The equilibrium constant for the electrochemical reactions, the equilibrium constants, the reactions are given here is Fe3 plus Sn2 plus gives reduction of the Fe2 plus and the oxidation of the tin ion Sn2 plus 2 FeSn4 plus is oxidized, and its reduction potential is given here. Reduction potential of Fe3 plus 2 Fe2 plus is 0.77 volt, and its reduction potential of tin is given Sn4 to Sn4 plus 2 Sn2 plus is given as 0.1515 volt. Since ion is getting reduced and tin is oxidized, this reduction potential is inverted, and the value they have given is 2.303 RT by F is equal to 0.06 volt. This question is a much more useful one, and questions are frequently asked based on this concept. Let's see the question. Let's see how to solve this. This is the equation. 2Fe plus Sn3 plus Fe3 plus Sn3 plus gives 2Fe. Fe ion 3 plus is getting reduced to Fe2 plus. Tin is oxidized from 3 state to 4 plus. The number of electrons involved here is, since the number of involved here is n is equal to 2. Here we are not calculating the E, we are going to calculate the equilibrium constant. Delta G is equal to, we know that already, delta G, change in Gibbs energy, is equal to minus NF E naught, otherwise minus RT ln K. So minus RT ln K is equal to minus NF E naught, minus minus getting cancelled. This value 2.303 RT they have given already as some value is given here, given in the questions. 2.303 RT log K is equal to NF E naught. Here log K is equal to, when I rearrange these equations, the equations will become like this. When you substitute the values, this 2 into when you bring the F here, 2.303 by RT by F, the value is given as 0.06. When you calculate the E naught, 0.75 minus 0.15, it will become, and multiply, it will become 0.6. When you rearrange the whole equations, we will get the value become log K will become 20. When log K is 20, when you rearrange the equations, the K, that means the equilibrium constant, will become 10 power 20 is the answer for these questions. Usually questions like this has been asked in many competitive examinations. Now I'll see the next question. The potential of the Debye-Heckel theory is proportional to, this is a question I have taken in the competitive exams. The potential of Debye-Heckel theory is proportional to the values, some of the values given here. This question is also given in the, this information is also in the Puri and Sharma and Patani of physical chemistry, in the electrochemistry third part they have given here. According to the Poisson equation, del square psi is equal to minus 4 pi EIP. This is rho is the potential charge density. So when you rearrange this, ER will become psi is equal to ZeER or e power, this is kappa r. So this is the e power minus kr by r is the kappa r by r is the total potential in the Debye-Huckel equations. This is given in the book directly. So since Debye-Huckel theory, the potential is proportional to the k e power kappa r by r. This is the options they are given in the questions. Now see the next question. If the concentration is increased to 4 times, this question is also important. If the concentration C is increased to 4 times its original value, the change in molar conductivity for strong electrolytes, where B is the Coulthard constant. This is from the Coulthard law. Based on the Coulthard law, the Coulthard law becomes lambda m is equal to molar conductivity, lambda m is equal to lambda m naught minus B root C. When you rearrange this, they have asked about the change in molar conductivity. Lambda m minus lambda m naught is equal to minus B root C. And since the concentration is increased to 4 times, when you put this here, lambda m minus lambda m naught becomes minus B root 4C. So lambda m minus lambda m naught will become, rearrange this, minus 2B root C. When you see, in order to calculate the difference between the molar conductivity, we have to subtract the equations 1 and 2. So we will get the difference in molar conductivity or change in molar conductivity becomes B root C. Now we'll see the next question. This is a question, which is the correct Nernst equations for the redox reactions. They asked about the redox Nernst equations. Nernst equations is not in the Polytechnic syllabus, but this is questions they can ask the questions, but this is in the PG syllabus. Oxidation, this is the O means oxidant and R is the reductant. O plus N electrons gives getting oxidized, plus N electrons getting reduced. So they have asked about the options are given here. We have to rearrange the Nernst equations according to the options. So the Nernst equation is E is equal to E naught minus RT by NF ln concentration of the reductant by concentration of the oxidant. Since they have given us oxidant by the reductions, when you rearrange this, the minus value will become plus, the denominator will go to the numerator. So oxygen will go, concentration of oxidant will go above and the reductant will go down. So E naught plus RT by NF ln concentration of the oxidant by concentration of the reductant. So when you rearrange these equations, ln concentration of the oxidant by concentration of the reductant is equal to NF by RT E minus E naught. So when you rearrange this, concentration of the oxidant by concentration of the reductant is equal to E power NF by RT E minus E naught. These are options given in the questions. Now the next question is, mean activity coefficients of the electrolyte K to SO4. This is a question I have taken directly from the book. The mean activity coefficient of the electrolyte K to SO4 and its activity are related by. The activity and mean activity coefficient, this is in the Polytechnic TRB syllabus and also in the PG syllabus also it is there. The mean activity coefficient of the electrolyte K2SO4 and activity are related. This is the activity coefficient and its activity, they are related using the formula. Since it is a K2SO4, we have to put this is activity is equal to x power x, y power y, gamma plus or minus, this is the activity coefficient, m, this is the concentration, whole power x plus y. Since these are the number of cations is equal to x and number of anions is equal to y. Since K2 is become 2 concentration, 2 cations and 1 anion. So when you rearrange this, when you put this in the equations, the activity is equal to x power x, 2 power 2 plus 1 power into 1 power 1, gamma plus or minus m power 2 plus 1. Its value will become 4 gamma plus or minus whole cube m cube. This activity is equal to, this is the activity coefficient. Activity and activity coefficients are related in this manner. This is such an easy questions, so always, and also questions like this is also asked in the competitive examinations. Now see the next question. Incorrect statements for the De-Broglie limiting law. For the De-Broglie limiting law, the incorrect statement is given asked here. These are questions I have taken on my own from the book, from the Puri and Sharma and Patania. I have taken these questions based on the concept like, when you read these questions, you will learn at least 5 concepts from these questions. It is not such treated as a question, but it's a learning question. In the De-Broglie limiting law, it is also in the PG Polytechnic syllabus and also in the PG syllabus. The mean ionic activity coefficients of the solutions. The mean ionic activity coefficients log gamma plus or minus is equal to minus 0.509 modulus of Z plus and Z minus. Z plus is the charge of the cation, charge of the anion, I is the root I. So, and the second one is minus a negative value of the log, like negative value of the log here, this negative value. In this equation, he implies that the mean activity coefficient is less than unity. It shows that the activity coefficient is less than unity. Since its value is given as minus, the activity coefficient should be less than 1. This is also an assumption on the statement from the De-Broglie limiting law. The limiting law equations is valid for dilute solution. This limiting law value is used only for the dilute solutions, because at higher concentration, what will happen in the higher concentration? Because at a higher concentration, the concentration values even exceeds the unity value. It will exceed the unity value, so it cannot be used. So this is the assumption in the De-Broglie limiting law, DHLL. And the fourth one is, according to DHLL, if Z plus charge of the cation, charge of the anion are same, if they are same, the activity coefficient should vary only with I. So if both are the same, it will vary only with the I of the solutions and not with the nature of the electrolytes. So if the charge are same, the coefficients, activity coefficients vary only with the I, it will vary only with the I and not on the nature of the electrolytes. It is also for the all other ions like different salts, it will be same, it will not change. It depends upon the nature of the, does not depend upon the nature of the electrolytes. So in these questions I have asked for the incorrect statement, but all are same, all are correct, all are correct. So we have to put one more options, all are correct. So this question I have taken in order to as a learning purpose, not for the testing purpose. I will go to the next question. This is the next question. This also I have taken on my own. If the electrolyte NaCl, this is also in the Puri and Sharma and Patania book. If the electrolyte NaCl, CaCl2 and zinc sulfates, and the curves in the graph x, y and z are respectively. This is the graph log gamma plus or minus and root I. The values are given here. If in this graph they have given x, y, z, what is the x, y, z represents for this NaCl, for these salts? Since we have seen already, if it does not depend upon the, it depends only on the charge of the cations and does not depend upon the nature of the salts. Since I increases, this is ionic strength, as the I increases, the charge, the curve will go down. So I is the most value of the I will be higher for the zinc sulfate. Zinc sulfate will have the higher value of I, so it will goes below to the x-axis. When CaCl2 has the next higher I value, it will go to the y. NaCl has the least I value, it will be the z. So questions are also will be asked based on these concepts, because activity coefficients will depends upon the I. As the I increases, it will goes near to the x-axis, otherwise it will goes above the x-axis. I'll see the next question. This is eta. When eta is a small, is the overpotential. This is in the Polytechnic TRB exams. When eta is small and positive, the current is dash, I is equal to, I is the charge density, eta is the over potential. And I is greater than 0 and eta is greater than 0, when eta is small and negative, the current is dash, I is greater than 0 and eta is greater than 0. This from the book I have taken Puri and Shama Patania, but questions will be like this will be asked. These are our potential equations. Eta is equal to RT by F, I by I naught. This is a graph. When eta is positive, small and positive, when eta is small and positive, it will be anodic, because anodic reactions will be, if it is positive, it will come in this quarter of the quarter positions of this graph. If both are positive, I and eta are positive, it will come here. If I and eta are negative, it will come in this quadrant. If it is coming in this quadrant, both are positive, it will become like a positive, that means anodic reactions. And if I is small and negative, it will be like a cathodic reactions. So these are from these options. If I is small and positive, it will be anodic, and I is small and positive, it will be cathodic reactions. This is a anodic part reactions, and this portions will be like a cathodic part reactions. And the equation is eta is equal to RT by F, I by I naught. And then the x-axis we have to take the current, and the y-axis potential or potential will be taken here. I'll see the next question. The sparingly soluble electrolyte. The sparingly soluble electrolyte M2X ionizes as M2X 2M plus and X2 minus. It is a sparingly soluble as ions. The solubility product, and this question like this will also be asked. The solubility product Ksp of the molar solubility, and the mean molar coefficients are related by the questions like this will also be asked in the previous PG questions, PG syllabus. PG questions are there, but this I have taken from the book directly. For this complex, M2X is equal to 2M plus and X minus. They have asked about the solubility product. The equation is M2X plus M2X equilibrium between 2M plus and X2 minus. The solubility product is its coefficients 2S, since becomes 2S. If you take a concentration as S, it will become 2S and single S. 2S gamma plus or minus square, S gamma plus or minus, since its charge is, since it is only one ion, we have to put only one. It is two ions, we have to square by 2. So when you calculate this, it will become 4S square gamma plus or minus square into S gamma plus or minus. So its value will become 4 S cube gamma plus or minus cube. So solubility product will become 4 S cube plus gamma plus or minus cube. So like this we have to calculate the solubility product and solubility. S is the solubility and its mean molar coefficients are related by like this. Now the next question is, this is from the photochemistry I have taken physical photochemistry. These are the questions not from the previous questions, competitive examinations, but I have taken directly, and these are much more helpful to you to learn the concepts. In this case, in a case of static quenching of fluorescence by a quencher, the value of tau by tau naught by tau is the lifetime of the quencher fluorescer. In the absence of the quenchers, it is in the presence of the quencher. Tau naught is the lifetime on the excited state of the fluorescer. In the excited state, in the absence of the quencher. T is the lifetime of the fluorescer in the excited state in the presence of the quencher. Tau naught by tau in the static quenching. So I will give you the informations in the next page. These are the informations. It will be much more helpful to you for the competitive examinations. Quenching is either static or dynamic. It may be either static or dynamic, but not both. If it is static, tau naught by tau will become 0. If it is a static quenching, the tau naught by tau will become 0, 1. If it is a dynamic quenching, tau naught by tau is equal to, it is the fluorescence constant, fluorescence in the absence of the quencher and fluorescence in the presence of the quencher. tau naught by tau is equal to fluorescence intensity of the fluorescence in the presence of the quencher, in the absence of the quencher by in the absence of the quencher, the presence of the quencher. These are the F naught is the intensity of fluorescence in the absence of the quencher. This F means intensity of fluorescence in the presence of the quencher. Now slope falls from the Stern-Walmer equation. The terms falls with a T. That means with the increase in temperature the slope falls, but it rises with increase in temperature. The Stern-Walmer equations I have, and these are the informations for the Stern-Walmer equations. The absorption spectra changes. For a static quenching, absorption spectra changes, but for the dynamic quenching there is no change in the absorption spectrum. From this we can differentiate between the static quenching and the dynamic quenching. So next question is, questions like this will also be asked. We have to learn this. Caffeine reduces fluorescence of riboflavin by dash quenching. Caffeine is a molecule. It reduces the fluorescence of a riboflavin by dash quenching. Caffeine forms complex with the riboflavin due to static quenching. So during the static quenching, the quencher and the complex will form a complex, and the fluorescer will form a quencher. The quencher and the fluorescer will form a complex in the static quenching. These are the informations for the static quenchings. Now the next question is, phosphorescence is a slow process because phosphorescence is a slow process because it is in the Jablonski diagrams I have given already. It is a transfer of the molecule from the triplet state to the singlet states. When you are transferring from the triplet states to the singlet states, it is a forbidden transition because spin states is not matching. So it is a forbidden transitions. So it is a slow process. Questions based on this concept will definitely be asked, at least in many competitive examinations. I'll see the next question. The incorrect statement about this excimer and exime plus are in the syllabus for the Polytechnic only. The incorrect statement about the excimer. Excimer is a short-lived excited dimer. They are formed only in the dimers, in the excited states, but they are not available in the ground states. These are the main difference between the excimer and exime plus. Dimeric or heterodimeric molecules formed from two species. They are formed between the two species. It may be a dimeric or heterodimeric. At least one of each molecule has completely filled valence shell. This is a main important property of the excimer. It should have at least one component, one of its components should be completely filled valence shell like noble gases. So they are used as a quencher in the excimers. When the excimer return to the ground states, they will not dissociate. This is the wrong answer. I have told you, when the excimer return to the ground states, they will dissociate into its constituent molecules. The wavelength of the excimer's emission is longer than the excited monomer. The wavelength of the excimer's emission is longer than this excited monomer. So these are the important points about the excimers. This question I have taken from the book, not for the testing purpose, for the learning purpose. From this we can learn at least 4 valid points for the excimers. So only thing is that this is a wrong option. When the excimer return to the ground state, they will dissociate. This is the important thing. Now the next question is the incorrect statement. The unit of KSV. This is from the Stern-Walmer. KSV is a Stern-Walmer constant is per mole. Questions like this will also be asked. Unit of Stern-Walmer is per mole. The KSV measures the quenching efficiency. This is the main important points. The main use of KSV is it measures the quenching efficiency of the quencher.